All right. Can everyone hear us okay then? Okay, just making sure. Sorry, we had hat day at the elementary school, and I'm not coming to you with a whole hat head today. So I don't usually come to school like this, but you know, any day that I don't have to do my hair, I don't have to get up like a half an hour extra early, I'm game for it. So, all right, well, again, I'm Alicia Korth. I teach first grade here at Lincoln Elementary in New London.
And I'm Lynn Shaw. I teach 7th grade here at the middle school in New London.
Welcome back to those of you that we saw last week. And for those of you that we might not have seen last week, welcome back too. So, just making sure everything was okay. Did anybody have any questions with getting in or Edmodo at all? If you do have some questions, it's probably best just to chat it out. We'll kind of just get started with our stuff. I know a slide's coming up with any questions you might have had. Today's focus is really going to be the math teaching practices 1 through 4. We had asked you to do a little bit of reading for today's webinar, and we're going to kind of just dive right into that. So I'm going to actually put our video down so you can just see the PowerPoint.
And then I don't have to see myself, which I'm not a real big fan of.
So again, any questions or comments that you had from this past week's reading? We did look into Edmodo. We didn't see anything updated at all, so we just wanted to make sure that we hit on that if anybody had anything to share at all with that.
If there's anything even that after last week's webinar that resonated with you that you thought about and something you want to share that way too, you can absolutely do that. So if there's anything, there's a small group. So if there's anything that you would like to talk about, we can do that, or we can get right into the PowerPoint.
Not seeing anything. If you have anything, just pop it up in there. We can always come back to it and stuff. We had discussed at the end of last week, we kind of ended off with this whole idea of productive beliefs as far as ourselves, as far as our districts, as far as our students and stuff. Just to kind of rehash over that, what is a productive belief that you see happening either within your district or even within your building? If you wouldn't mind chatting that out. We had mentioned last week, we're not going to have everybody share in a discussion because we get this feedback back with our microphone. So the best way we found is to kind of just throw it up in a chat and then we kind of discuss it together.
And then you can, if you use your microphone, then there's no feedback. Like right now, there's a little bit of feedback from someone. So. I'm not sure. So, okay.
So if you have any productive beliefs, if you wouldn't mind chatting that out. Like in my school, I feel like we are at the elementary level, and even I would say upper elementary level, we really are doing a great job of trying to have our students do a lot more of the talking, and they are coming up with questions that they might have. They're coming up with reasonings why they think something is being done. And it's not so much the teacher now telling the students, hey, this is what you're going to do. It's really fostered around our students in our classroom and going from there.
And I think in the middle level, you know, we went to, there was a good chunk of us that went to the Wisconsin State Math Initiative, WSME, this summer in New London when we hosted. And our focus, I think, actually, and our plan, K-12, was going to be multiple representations. So I think that that's somewhere, you know, that's a place that we're trying to get to, that there's not only just one way to do it, that you can, there are other ways to get there, but then also there's a step further in that, that's the justification. So our students here are working at multiple strategies to justify the reason.
If you want to, if you are thinking, hey, how can I share this productive, unproductive beliefs and stuff, you can actually always refer back to page 11 in the Principles to Actions book, and that will actually help kind of review some of those ideas of those productive and unproductive beliefs. I didn't see anything else get chatted out, so we'll just continue on. From there, we remember we're trying to add some of that Edmodo online discussion. We actually took the polls that we had in our PowerPoint from last week. They really don't work in Zoom, so what we did is we uploaded those into Edmodo. And what I found interesting as we were looking, we could see the people that got logged into Edmodo, and then they answered those polls. And overall, many people had kind of discussed that, yes, they felt those productive beliefs were happening in their district. They felt they were doing some productive beliefs. I know there were a couple of people that had felt that their district still had some of those unproductive beliefs. And I think that's a great place to start and to kind of foster some of those discussions of how can we get to more of a productive belief. Remember, it's not, this is a good productive beliefs and the unproductives are really bad. It's just more to kind of think and reflect on how can we as educators really get to have this proficient math environment for our students.
I think too, part of the thing that I love about Principles to Action is, as an educator, there's a lot of things that I do that are progressive, I would say, in terms of that book and those productive beliefs. But I also think that there are times that you just start getting into, I don't want to say a rut, but it's kind of like a rut, and you start going and, like right now I have 3 other math teachers that teach 7th grade math here at New London in the middle school. And I feel, and I'm behind them. I'm quite a bit behind some of them. And so I feel like I'm rushing and trying to catch up. And when I thought about it yesterday, and I thought, that isn't what's best for my students. So you know what, if they're ahead of me, they're ahead of me. I'm not going to worry all that much about it. So, you need to be reflective and think back to what you are doing. So.
I think you have an interesting, I think somebody's microphone might be on, just so you want to check if you're muted.
Okay.
John, I think you bring up a really good and valid point. He just said that, and I'm not sure if you guys can see this, that he feels kind of sometimes those curricular areas are disconnected from the math areas. And I know we're trying to make kind of the seamlessness, not so much, if you ever study Linda Dorn, she has a very silo kind of curricular areas, and trying to have it not be so silo-like. I think that's key too. We meet in our district, the math people meet, and then you have the reading people meet. But I think as well, we need to have discussions across curriculums. In my level, it works okay because at the elementary, we teach reading, we teach math, we teach the science, we teach the social studies. So we do meet and we kind of discuss all those, but I can see how there's definitely that disconnect sometimes, especially as we get into areas where you're like Lynn's only teaching math or English.
I think, it is, I do think it is an issue. We do in New London, we have a PLC, Alicia was saying, we have a PLC for just math district-wide, but we also have a PLC building-wide, and then we also have a PLC in our team, and we meet 2 or 3 times a week and have discussions about students and have discussions about curriculum. One thing that just came up, our social studies teacher here in the 7th grade had asked last year, had asked me if there was a way that she could integrate math into social studies, because obviously reading is easily integrated into social studies, but she wanted something that would be a little bit more challenging. And I was like, oh my gosh, there's so many things we could do. Because in social studies, if they're reading graphs or charts or whatever, you can apply that to statistics, you can apply that to RP, ratios and proportions, or algebra or linear equations. So it really is possible. You just have to, and this is the big $1 million problem, if you had more time. Time is always going to be an issue, and you have to be able to find or make that time. So, but that is a great way. And she used that as her SLO goal and then her PPG as well. So, which is kind of cool. So the collaboration piece, so something to think about.
So thanks for sharing out those ideas about Edmodo and stuff. We're going to continue on kind of looking at our overview of today's webinar.
We are going to cover the math teaching practices 1 through 4. We will do some examples of teaching practices in action, and then we'll also have some discussion. And we have that we're going to C, that is one of Alicia's favorites. And then we're also going to post some that we have online. When we were creating this webinar, we really strive to find things that you could actually look at in terms of things that you could do in your classroom and use within your classroom, because that is key. I think you want something that you can take from this and utilize to help you and help your coworkers integrate these practices. And then the other thing is just some videos so you can see what it looks like in action.
So we'll share those resources, like always, onto Edmodo. And if you have anything that you will be willing to share, by all means, please add it out there as well. We want it to be really that open discussion for everyone. So again, here's our learning targets for today that we're going to really identify those math teaching practices today. We're going to explain how these practices really help impact our student learning, and then determine how it would look, sound, and feel in your classroom.
The practices that we're going to look at are the ones that are in pink. So establishing math goals into focus learning, math goals to focus learning. That is a real biggie here in New London. And there's actually an article that I'm going to share on Edmodo if you are interested. It came from another facilitator from WISME. He had sent it to me, and I thought it was really interesting about how sometimes goals can not necessarily foster that in the moment kind of teaching, that teachable moment kind of teaching. So, but we'll talk about that. We're going to do some implementing of tasks, or talk about implementing tasks that promote reasoning and problem solving, and then use and connect mathematical representations. So this would be those multiple representations to show why, or to justify why something is the way that it is, and then to facilitate meaningful mathematical discourse, which I think is really, really important.
So to really get those math goals to focus on the learning, we want to just come up with, and have you just chat out, how often are you really required to have your goals visible, or how often do you put your goals out? Just chat out, do you have to do it every day? Do you do it most your days? Is it, once a week, once a month kind of thing? How do you share out the goals? Okay.
So it looks like everybody is saying that they have them visible every day. I don't know, in my room, I do an I can statement in 7th grade. So my goals are essentially a breakdown of what those standards are from the Common Core state math standards. And what I do is I change it into kid-friendly language, middle school-friendly language with an I can statement. And we do it every day. So math teaching practice 1 is to establish those math goals to focus learning. Effective teaching of mathematics establishes clear goals for the oh my gosh, I can't read today. For the mathematics that students are learning. It situates goals within learning progressions and uses the goals to guide instructional decisions. And I think sometimes as math teachers, I've had math teachers that were talked like way up here above my head. And I think sometimes we can be guilty of doing things like that. So I think that first part of making sure that it's clear to the students, because that's really what the goals are for, not for you, they're for the students. So making sure that, that you're doing it in their language that they can also understand. Now, I also feel very strongly about vocabulary, because there are some teachers that sometimes will make it too easy and take out that vocabulary, and I use that vocabulary readily in my classroom. So I think
just like Lynn had kind of said, in a moment we're going to show you a couple of different examples that we have found that I use and she uses within her classroom. But this quote actually at the bottom here comes right out of your book. It's on page 13. We found that many districts try and have different ways that they want goals represented and stuff like that. I think the biggest thing is, that you're referring back to those, so that way those clear expectations are really set for your students. So like I said, here's an example of what you might see within an elementary level right at the top. Again, that I can statement. What I have in my classroom is I've actually kind of gone away from these posters because I had so many different math practices or math standards I was hitting. The kids and I come up with something that we designed together. And the interesting part is I try myself to have the students continually refer to it throughout my lesson of what is their goal for the day. What am I presenting, but what am I expecting them to really kind of walk away with? And I think that's the most powerful thing there, because they then put it in their own terms of what they really are trying to learn that day.
Right. There are times too in my classroom where, especially if we're continuing from the previous lesson, that I'll have my students write the goal. And or like today, I actually did this today. We're wrapping up the first chapter of RP, and we're moving from, or making that connection from ratios and proportion and constant proportionality to direct variation and algebra and the linear equation. So what I did today is I had them specifically identify, we had our goal on the board, and then they had to, as an exit slip, as a nice wrap up, they had to identify how they did those things, or how, justify, how do you find the constant of proportionality, and what is the relationship between constant of proportionality and slope, and things like that. And it's hard for them to verbalize that, but I think it's really important that they do. So like Alicia said, I think it's super important not just to put it on the board, but to refer back to it for them. And it's a great way to close your lesson.
Mm-hmm.
So
now we're showing kind of something that might be posted up in the classroom. Goals don't necessarily have to be posted right away in the classroom. Maybe you have something on your slip of paper or whatever your
Right.
students are working on, like your math tasks you have them doing. Maybe then your goal is right on the math task that they're going to be doing, or they're coming up with it with you. Like we said, there's many different ways and variations that you could actually have clear learning goals for your students. I think the essential key part, though, is that they're understanding it and why they're doing it. Because otherwise, it has no meaning to those students at all.
right. I think it's important to try to connect it to them.
So we're moving into math practice 2, and that's implementing tasks that really promote that reasoning and problem solving. A lot of times people ask, what makes a good math task? So what might be created within it? We found this cute little video. It's one of my favorites. I always have to share it. It's from a Kid Snippets, and I just want you to kind of look at it. It's humorous of just what's kind of going on within this math class. And we'll talk about then, what makes it just, a non-effective classroom environment. What do we really need to actually have those good math tasks?
This will give you a nice little laugh at the end of a day. So enjoy.
So here you go.
Hold
Sorry,
on
we're
just one
just gonna
second.
make
We're going to
sure-
make sure the volume is up because and it's not. Yeah. There we go.
Sorry about that. Just want to make sure you can hear it okay.
Takeaway 5. 1, 2, 3, 4, 5, 6. Takeaway. What's 6 takeaway 1? No. Takeaway. So you take away 1 out of 6. How about you? What's 5, 10 minus 1? I don't know. 1, 2, 3, 4, 5, 6. 6, 7, 8, 9, 10. Nope. Take away 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 1 more. Add 1 more. 1, 2, 3, 4, 5, 6, 7, 8. Equals, it makes 9. See how you take away?
So I just always love to share that video because as we're talking about these different, math implementation of tasks or implementing math tasks, what does it really mean? What do we really want to be showing? What do we really want to see? Why am I not? Oh, thanks. So, as you could see in the video, I just always love that one. Obviously it wasn't a rich math task. The student wasn't problem solving on their own. They were struggling with it. And the teacher was struggling too with trying to get them to really understand what they were trying to do with it.
I think we've all been there where you've been saying something like that and you're like, okay, wait a minute, why aren't you getting it? And it's like they're stone-faced, you're wondering if they're even alive or if you're speaking some other foreign language. So
the interesting part, with math teaching practice too is really, we always try to put out the whole practice here, but we really highlighted some things that we kind of took out of it. That solving and discussing, that rich discourse that your students and you are having to really engage with students. Also, problems that don't have just one way of solving them, but that can have those multiple entry points and different strategies that could be used for students to really apply what they know and what they understand about the problem.
those last two are really important too. And if you can have a task that you're able to do that you have those multiple entry points, there's lots of ways that you can do it. And you have varying strategies that can be used. That's huge when it comes to differentiation. I mean, that leads easily into differentiation within your classroom. So if you can find those tasks, they are wonderful.
Okay. Thanks, Joey. Is anybody else having any issues with the sound? We can hear people. I just want to make sure that people aren't having a problem with it either.
No, I got sound now. I'm good.
Okay. Thank you. Thanks for letting us know. It might have been just something from going from the video back to our computer screen and stuff. So just kind of thinking about these rich math tasks, here are some ideas that actually came from Principles to Action's book. These low-level cognitive demands is, again, that memorization, just procedures, remembering which routines they had to do, and there's no connection or meaning or concepts that was behind it.
Like, when you think about that, if you're trying to think of something, to me, I always think of the cross-product method, when they're doing cross-multiplying to solve for a proportion. Kids have no idea why they're doing it. Teachers have no idea what you're doing and what's happening there. But I think if you can guide through all of those steps, it's really funny because now my students always used to go directly to that and that was their go-to. And now there's so many different ways that they can solve it that's rarely the one that they choose. So I do think that they have to make sure that there are connections and that they understand why you're doing what you're doing.
So kind of thinking of what are some examples you might see. When I'm guilty of this. When I would do the fact families up to 10, I would just teach my students, oh, you can take a 1 and a 9. And then look, we can actually take 1 from the 9 and switch it over and add it to the 1. And now you have 2 and 8. And it was just kind of a routine. It was a memorization. There was no thinking really behind it except for what the students were supposed to be copying down. And I mean, that was just something that I hadn't known at that time. I was just thinking that I was helping my students really understand when really there was no meaning or thinking behind it, that they were coming up with that. So now what I try to do is I try to give them word situations such as the one that's on the right-hand side with that higher level where they have a total of 8 cars per se, or it could be, M&Ms or something that relates to them and their real world experiences. And they have to come up with different combinations to show a total of 10, and they can actually come up with different solutions. They can show it using words, using drawings, different multiple representations, and they are the ones that are actually explaining it to me, and I might just be asking some questions along the way to really judge their understanding and to maybe, if they're getting stuck on something, to kind of redirect them to.
Right. I think when you get into the I think high level ones are next,
Yep,
upper level ones. But when you get in, never mind. We're going to let her.
So this is just an example of the drawings and stuff that I might see, a first or a second, or even some of my kindergartners, they might not be going up to partners of 10, but they might be drawing something like this in their math journals. That's something that we do in my class. So then here's the middle school that Lynn was talking about.
Right. So like when you're talking about examples of high level or high level tasks and demand, I think we fall into that old school rote learning, real quick, no context. And unfortunately, then that results in students being terrified of a word problem. And I think if you do more word problems, I do more word problems than I do what I call naked problems without any context. I may only do one, if that, two naked problems, and the rest of what they have is word problems so that they can see it in a variety of situations. I think that they then have to, and it's hard sometimes for some students, especially those students that may be in special education and may have a reading disability. So then you have to, work through that and read through some of those things, but they can do it. And the more you do it, the more familiar they are with it. So this is just an example of something when you're talking about ratios, 5 boys for every 4 girls, you develop a word problem, have them then develop the word problem. I do that all the time. This is our situation. Now you come up with it and then you solve it and show me it in multiple ways. So
then this might be then the way that they could set it up to actually show their thinking with
right.
it. So
we do tape diagrams, we do double number lines, we do a lot of ratio tables. I have kids, I have a problem that we do in RP for WSME that is about caterpillars and leaves, and I've had kids draw out the leaves, to show what they had for their grouping, and there's nothing wrong with that as long as they can then see and understand what they're doing. And our goal, I want you to, I don't know if there's high school and middle school teachers in here, our goal is not, some people will say, well, why are we drawing in math? They're supposed to be doing the symbols. Our goal is to get them there. But not all kids are there. And that doesn't mean that they don't understand what you're doing or the process that you're trying to teach them. It just means that right now they're not ready for that algorithm or that symbol work, And so I think it's our goal is to get there, but we're not all there. Not all students are there.
So then we were thinking kind of, what might be a high school example then, Here we had a teacher instructing between that difference between standard and function notation and graphing functions when the constant is added to a known function. And then I think the shift is, and it's interesting is, before.
I think that low-level test scares me.
Yeah. Before it's very teacher-directed,
right?
But we have to be willing to kind of give over the reins, whether it's elementary, middle, or high school, is to really let our students then start discovering this through their tasks that they're doing.
Right.
And you can see that on that higher level side where the students will be using what they know about lines and how intercepts create parallel lines
and
to continue.
Sometimes that's scary to give them all of that control, but I firmly believe that is really when a lot of that learning happens. Good learning happens. And I think, there's so many teachers that are afraid of that. And when I think of it, I think of technology even, they're afraid to go out on that limb, but you'll be amazed at the results that you'll receive if you do.
So then here are some different functions that they might be able to graph. This was taken from Big Ideas in Algebra 1 just as a task that they had there. And then if you notice, in their own words, they have to describe different things that they're looking for with that standard notation and function notation, and then kind of look at what their observations were and compare it with different graphs.
Right.
So math teaching practice number 3 is really, again, going back to those different modes of representations. We talked about this actually in the first one where we did our introduction, where you can see, some representations might be visual, symbolic, physical, acting it out and stuff, that contextual, putting it into their real world terms. I do that a lot with my students. A lot of them, they might really like candy bars. So then we have something about candy bars or something like that. Today's problem, they had something about a king and a queen with a castle, and it was well, nobody in my class lives in a castle or might have seen a castle, so I need to really bring it down into their world so that way they can have this connection and have a deeper understanding.
It really is important so that it is something that they can relate to. That really is key, because if they can relate to it and if they can see, hey, I know that. Like, for example, I did some of the editing or whatever for the forward exam for 7th and 8th grade this summer in August. And when if you have a problem that talks about deer hunting or duck hunting or something like that, students in Milwaukee or Madison may not know what that is. You know, they may not have a clue of what that is. Or one other question, like we talked about too, if you have a museum, there's a question that we have in our book about going to some whatever museum. Well, we have a lot of kids here in New London that probably haven't really been to a museum, not a true art museum. So I think that it's important that you bring it down to their level, and then keep in mind that the modes of representation,
So here might be a little bit of that lower level. We kind of are trying to give you ideas of, what might be a lower level task versus your higher level task. So this was one that we kind of came up with middle school. The probability of drawing a blue marble if you contain 75 red and 25 blue marbles. So then I'll have you talk to this one.
Well, what happened was, this is kind of funny because I brought this problem forward when Alicia and I were making this, and I'm like, oh, well, this is, very much middle school. And so we just showed that you have the 3 different bags, 75 red, 25 blue, and you're comparing, and they're going to come up with the probability of what would happen. Okay, so if you want to flip that. So I said, it was funny because we were talking about it, and I said, okay, these are the ways that my students might solve it. They might make a tape diagram, and they might make it in one, or they might make multiple ones where they're talking about red to blue, a comparison of red to blue. And we do lots of tape diagrams in 7th grade. And it was funny because Alicia then said, well, I can do this problem in 1st grade. And I'm like, get out, no way, And then she's going to, I think that's next.
So this is a little bit more of her
yeah.
her proportions and her ratios that she had discovered and stuff. But then
Maybe we didn't put it in. Maybe
I'm just going to go back. What we did though, if I would bring this down into an elementary level, what we found is we can actually still use these tape diagrams. So something that she's using in middle school, high schoolers use it first, or maybe not so much like the 1st graders are using the tape diagrams, but we're going to be solving it in a different way. I obviously won't be doing these fractions right away in 1st grade. But the interesting thing we found is if I'm introducing this type of tool already in the elementary level, what my students then see as we continue with these tasks over time, they're going to see that same tool. They now see how that tool is changing, evolving, being used in a different way. And they already are familiar with it and already comfortable in using it. So now it's not a problem of, do I not understand how to use the tool and how to solve the problem? Now it just becomes, how can I relate it and use it now for this word problem?
I think it's interesting because, it is something that you have to model. And you have to kind of train your students to do, especially I would say in the middle level, a lot of kids not really have done much or any tape diagrams. And it's funny because, I keep bringing them up for different situations and different problems that they're solving. And they really do, oh, could I use a tape diagram for this? Well, yeah, you could try to figure it out. So, it really is a way for them to organize their thinking, I think is really what it amounts to. They're organizing their thinking, and it becomes very visual. And the very cool thing about tape diagrams is that connects so nicely to algebra and in solving a word problem with an equation using variables. And they can then start to see, okay, I have 3x, if you look at the top one, I have 3x and 1 plus 1x, whatever equals whatever, 100 or whatever you're going to do. You're able to do that. Or if you look at the top one, it would be, 3r plus, 1b or whatever, rb or, you can make that algebraic equation. So there is that nice connection.
Then we get into Math Practice 4, which is meaningful mathematical discourse. And I think the essential key that we wanted to bring out of this is it's not just the discourse between the teacher and the students, it's actually discourse among your students. and they're sharing how they understand things. They're sharing and comparing what their peers did versus what I did. And they're looking at different approaches and why something works and why something doesn't work. Or I love it when, at any level, you have a kid that's like, no, that wouldn't work. And before I can even say it, another kid is saying, but it could work if they did this. And all of a sudden you have this kind of like nice bantering, if you will, back and forth, because each of them are trying to prove to the other one why it does work. And all of a sudden a light bulb's going on in both of their heads, because they can understand how each of them got to their solution or why it does and doesn't work. And it's not even coming from me. It was all them and their meaningful discourse.
It's really hard. Discourse is hard. I think it's hard because traditionally we weren't taught that way. You sit down, be quiet. This is what we're going to do. It was kind of that atmosphere. And now you find that conversation amongst your peers is really extremely meaningful to them and sticks more. I think they remember it more. I do this is something I worked on a lot last year, and it's something, again, you have to model. And it's really important that you do that, because I think they need to see what that needs to look like. So what I show them, like I've videotaped students with parental consent. I videotaped them last year, a couple groups really doing a nice job. And then I show that because it really gives them an idea of what that needs to look like. The other thing is I do this thing called, today it was awesome. I do this thing called a peer review. So they have their practice work and then they get together the next day and they have to partner up with, and sometimes I assign partners and sometimes they pick their own partners, but they have to then talk about their assignment and go through, how did you solve it? What did you do? And today it was so cool because I have a class that is an inclusion class that almost half of my students are special ed in that class. And the conversations that were coming from some of those kids were awesome. And they were arguing about why they thought, because of our lesson today was constant of proportionality, and why the constant of proportionality was this and why it wasn't. And then there was I always do a multiple choice problem every day so that they can get used to that, that standardized test practice. But they have to justify it in my classroom. So they had this huge discussion about why the answer was C and not the others. And oh my gosh, it was so great to see. And I think they feel really good about it too. And they really get then engaged in what you're learning. They have a stake in the game, if they're having that conversation with somebody. It is hard. It's not easy because, you do have to have a level of expectation, so my rule in my room is you're not allowed to talk about anything but math. It's like occasionally I'll have kids that'll be, all of a sudden I'll hear somebody's talking about the football game tonight and I'll be like, what? Football game? No, you can't be talking about that because that's not math, and so, and it is playful, but yet it lets them know that, hey, you need to get back to what you're doing and back on task. And it really is very, very meaningful to them. And any kind of collaborative work would give you that opportunity for discourse.
Like Lynn said, mathematical discourse can sometimes be one of the most challenging math teaching practices to really implement in the classroom, because you want to make sure that your students are, learning from each other, and you want to make sure that they're being, efficient in their math talk and the strategies they're using as well. We actually have a video that we have found. It's a little bit of a longer video. I believe it's about a 10-minute clip, and we always put it out on Edmodo. So please double check it this week when you get off here, and within the next week to next Tuesday, we will be putting that link up right away tonight. And what it is it's actually an algebra team, and it's strategies that work for really any age level, but it's actually an example of older kids and them using this math discourse to prove to each other why something worked and why something didn't work. Right. So we will have that out on Edmodo, and then we're going to actually have a couple of questions for you as well that you can answer back. But just kind of curious, how do you create some of that mathematical discourse within your classroom? Or I know some people, they don't have their own math classroom. They're going into other classrooms. Maybe you have ways that you've seen teachers create math discourse in your district. If you wouldn't mind just kind of chatting that out, what are some approaches that you've seen that have worked for students to really help with bringing this math teaching practice to life? I'll give you a little bit of time to type that up in there. While you're typing that in, how you kind of bring that to life in your classroom or even in your school. I've even done a nonverbal math discourse, and that's kind of fun. We actually did it just last week. It is a gallery walk, if you will, and the students, they have to solve something or a task or whatever they're doing, and then they show their work to try to prove it, and then they have to stand around, and we walk around and look at everybody's work and see the different strategies that were used. And what's interesting is nobody can talk while we're doing that. It's just a pure gallery walk. And then when we come back to our original spot, then I actually have the kids share out, well, what did you notice? What did you think about what you saw? And it's always interesting to me because the kids always come up with, well, I saw this happening, and they're not even talking about their own. They're actually talking about what their peer had done, which is really cool.
I think that what Kay said, that she looks for rich problems that foster communication and modeling what that communication looks like and sounds like. I think that's really important. I think if you have a good task, good tasks make this math practice, and really, to be honest with you, all of them 1 through 4 easy. Mm-hmm. If you have a good task, I think that is hugely beneficial.
I like this idea that John shared out. If a student was absent, they actually have, he has another student kind of share what they had done in class, or if they're unclear of what they had done, he has a student share. That's a great way to have the students really take ownership of what they were learning. And, also for you to judge, okay, did they really get it? Or do I have to do a little bit of reteaching, which is great.
I think, I always get the question when we're doing this, but how do you keep them on task in middle school? Because middle school is not easy. But, I've never really had a big issue with it, but I do think that you have to have a level of organization in your classroom, expectation, so that it's not a free-for-all. Because I think if you're loosey-goosey, they're going to be loosey-goosey in their behavior. So,
yeah, and Lori was sharing, that kids want to go right away to this equation. Mm-hmm. Even today, my students, we were doing word situations. I like to call them word situations because make it more real life. And they, there's some kids, they're like, can we write the equation? And I was like, well, where's your work? Like, prove it to me. What do you have to show to me? And they're like, well, can I just write the numbers? And I was like, no, you need to show it to me. I need a drawing. I need some kind of representation. You need to act it out or something with your manipulatives and stuff. And they kind of looked at me like, I can't just write the symbols, because I have kids in my class that they don't understand the symbols. They actually need the drawing out. So I'm trying to kind of bridge between the two different means, if you will, because some of the kids, they're very good with their equations, but then they really don't understand what those numbers kind of represent, what that quantity entails. So I'm trying to kind of do a little bit of each, if you will.
I think one of the things I was thinking when Alicia was talking, I have manipulatives in my classroom, and some people think, well, 7th grade, you have manipulatives. Manipulatives are awesome because, number one, they like manipulatives. Mm-hmm. So it's engaging. And I think if you use that word justify, justifying is important. They need to justify their answer. And they need to do it using a different method. I don't care what method that is, but you need to come up with a different method. And sometimes I make them come up with 4 different methods, mm-hmm. If they're working in a group. And we'll talk about that more next week. But I think it really is important. And I think that they do want to fight it. Especially, I have an accelerated class. That class does not want to go back, to right. drawing anything. They want to go to those symbols. But I think if you ask once, why do you do something? Like I asked them, they knew the cross product method. Okay, why do you do the cross product method? Well, I don't know. Well, what do you mean you don't know? When are you going to know? When will you know? If you know it, then go ahead. But if you don't know why, then you got to figure it out.
So this is the wrap up of our webinar for today. You have hopefully already joined our Edmodo group. That is the code for the Edmodo group right now. We will post all the videos that we had today. The links will be in our Edmodo page. We'll actually also post a couple of different questions that we're asking you to also answer and share out and kind of give your thoughts on it. We'll also have any resources that we had to share today. I know next week we will have a plethora of resources between Lynn and I that we've used in our classrooms or have gotten over the years that we will share out, and those are all going to be up on Edmodo. Some will be like a Word document that you can actually just print off and share with others. We'll put all of that out in Edmodo, but we'd like you to at least go in there, kind of look at the questions, view the videos again, maybe share any comments that you had from today's discussion or anything that kind of popped into your mind.
We will be putting also, there's several links to different places where teachers can get tasks at different levels. Because that's hard, coming up with one on your own. It's a lot easier if you can find, a place where they, have good, rich tasks.
So that will also be in Edmodo. So this week we covered just those math teaching practices 1 through 4, and we had asked that you read those pages. For next week, what we'd like is we want you to look at the math teaching practices 5 through 8 and read pages 35 through 57. Next Tuesday will be our final webinar session, and then we'll also still extend it open in Edmodo for further discussions and comments and thoughts and answering to different polls that we would have out there and everything. But then next week, we'll definitely cover those math teaching practices 5 through 8. So if you have any other questions, we'll be around for a little bit. Otherwise, thanks again for coming tonight and sharing your time with us. I hope that you enjoyed this week's webinar, and we'll see you on Edmodo and again next week.
Yes.
All right. Thanks, guys.
So happy. You're so happy.
I had a quick question.
Yeah.
I can't make it to our webinar next week, Tuesdays, so then I just watch the video clip online.
Yeah, I upload it to my YouTube account because I have a blended flipped classroom for my class, and so what I do is I use that in my classroom. Well, then I also created a page or favorites area for the videos that we've done. So we'll put a direct link to the video we do next weekend, this video and the one we did before on our Edmodo page. So you would just have to go to Edmodo whenever you have a chance then to view it.
Okay, I saw the link for last week's.
Yeah.
So it's something similar to that.
Correct. Yep. It'll be exactly the same.
Okay, thank you.
Not a problem.
Thanks,
Have a good
John.
week.
Yeah, you too. Bye.
Bye.